Okay, so I'm looking now, who's that? Oh, you're just laughing at me.
There's someone.
Alright. Is there someone outside?
No.
Alright, okay.
Someone outside here will not do that.
Alright, okay. Now, I'm going to do number 7 and 8. So, you'll have to just look at his number there, and can you share one maybe so she can see number 7, please? So number 7 is we want to prove that 3i minus j is perpendicular to 2i plus j. Isn't it? Sorry, 2i plus 6j. Is that right?
Oh.
Number 7.
Yes.
Yeah. What does perpendicular mean? Remember this?
Yes.
No, parallel. That's perpendicular. 90 degrees. Let's calculate the angle for each. So this angle is tan inverse minus 1 over 3. And then this angle here is tan inverse 6 over 2. Can you tell me what this is on your calculator, please?
The first one is minus 18.43.
So the first one is minus 18.43, so about 18. And what's the other one?
71.57.
Perfect. So if I was to draw this one, the first one is minus 18 about, so that's like down 18 degrees here. Then the other one is 72 degrees, so that would be like here, 72 degrees. So the angle in total between them, 90. You can see they add up to 90. So they're perpendicular. That's enough for that one, okay? And then what else did you say? What's the other one? 7 and 8, is it?
Yeah.
Okay. So you have here A equals 4i minus 2j, and then B equals 7i plus 5j. Find a t so that a plus tb is along the y-axis. Okay, so everybody look here please now. What you're trying to do is to find a t that makes this factor here on the y-axis only. So if something is on the y-axis, what does that mean for its values of I and j?
On the x-axis.
Yeah, it's on the x-axis, so what values does that mean?
1 unit.
Yeah, what's that, August?
No j.
No j. So the j part should be 0. Okay? Because if you have only an I part, it means it's like this. It's when you have I and j together that's like this, and then only j would be this. You know, you have I and j. Yes? What part?
The last part for I is
Yeah, this is I, this is j. So if you have this, it means it's only I. There's no j. So let's calculate this. A is 4i minus 2j, and TB is 7ti plus 5tj, which equals 4 plus 7ti. Yeah, so you write this down now. 4 plus 7ti plus minus 2 plus 5tj. But as August said, there's no j, so how big is this number here?
0.
Yeah, it must be 0. So you have minus 2 plus 5t must equal to 0. So t equals 0.4 when you solve that.
Oh.
Okay?
Okay.
So that is number 8, 7 and 8. Oh, they actually say in the question in number 8, the J part must be 0. If you look at,
Yes.
so they tell you this too in the question. Okay. Anything else from this now?
The first, the second one, in each case, draw the vector. You know,
Yeah.
if there's any
Yeah, that's, you see,
after, I found it, then after drew it.
this, the only reason they put the answer like this is because they can't really draw the answer on the back. So when they're saying NE, what they mean is the vector just goes perfectly northeast. So NE isn't really part of the answer, it's just because they don't have the space to put the answer at the back. So don't worry about the NE part, it's not for you. Once you drew your vector like this, 45 degrees, then that's it. Okay. Anything else from that worksheet? No? All good? Maybe? Okay, so we can start the next topic then, yeah? Okay. And let me just double check that the sound is on. Yes, I can see the sound's working there. Okay, new page, so. So like I said, last lesson on vectors, and then we'll start something new. And the last lesson is more just practicing with I and J. And it's more practicing, I don't know if you remember this word. Does anybody remember the word when you write one vector in terms of I and J, or in terms of two other vectors? I told you this earlier in the week. No, but that's the name of the graph, yeah. Do you remember resolving? Resolve.
Yes.
Resolve means to write one vector as two vectors. So let's practice some with I and J, okay? So for example, here's my vector here, and let's say its length is 10, and let's say the angle here is 45. And I want to find the I part.
Oh.
You know where this is going? And I want to find the J part. Now you can use basic middle school trigonometry here. Okay? You all know trigonometry? What I mean when I say this? So you call this part X and this part Y. Who can tell me what cos 45 is equal to here? Who remembers this from middle school?
1.
No, I don't mean the number. I mean on this triangle. Not Y, no. X over 10. X over 10. Okay? And then who can tell me the sine 45?
Y over Y.
Y over 10, very good. So if I want X and Y, all I do, bring the 10 up here, bring the 10 up here, hit this in on my calculator, and you'll find your calculator will give you an answer of 10 over root 2, or other calculators might write it differently, like they might write 5 root 2, I think is the other answer your calculator would give. They're both the same number. Anyways, I don't mind. You can use a decimal if you wanted to do. So there you go. X is 10 over root 2, and Y is 10 over root 2. So the answer here, this vector would be 10 over root 2I plus 10 over root 2J. So I've put this vector as 2. This is so common of a problem. It's so frequent. You need to be perfectly clear on how to do this. let's have a look at another example. So in this next example, I'm not going to tell you the angle, so I'm just going to say it's here, it's 5, and this is alpha. And again, you want to find the I part, and you want to find the J part. So just like before, xy, cos alpha equals, what's alpha? Cos alpha equals
X
X
over
over 5.
sin alpha,
Y over
and no problem here, 5 comes up, 5 comes up. So you get your answer is 5 cos alpha I plus 5 sin alpha J.
That's it.
Yeah, that's it. Now, they could make the question more complicated, so I'll give you one to try, okay? Okay. So let's say now, this here, vector here is 3 units, and the angle is 20, well rather, I'll make that 30 degrees. And then let's say I have a vector here, and the angle here is 45 degrees. Okay, and then this is, let's say, root 2. I'll change this size now. I'll make this I'll change this a little bit, make it easier for you. I'll make this 60 and I'll make this 2. So there are 2 vectors here. What I would like you to do as 2-step problem, one is to write each using I and J. Do that first. And then secondly, I want you to add them together. So first, write each vector. So this is vector 1 and this is vector 2. Write each one as an I and a J vector. And then, after you do that, I want you to try and add them together. Okay, so get working on that now. Okay. Do we have the answer here? Okay, let's have a look. So if I look at the first one, let me draw the triangle in here. Here's the I part, here's the J part. I'll call this X, I'll call this Y. So cos 60 equals x over 2. So x is 2 cos 60. And then likewise sine 60 equals y over 2. So y is 2 sine 60. Now, 2 cos 60 is 1, isn't that right?
Right, 2 cos.
And then 2 sine 60 is
3 square root.
root 3 over 2, isn't it? No.
No, just 3.
Just 3 here?
Yeah.
Root 3.
Yeah.
Oh.
Yeah, it has to be because from Pythagoras,
Right.
1 plus 3 should equal 4, yeah. So we have the I and the j part for the first one. It's going to be 1i plus root 3j. Okay?
Plus
Root 3j.
AJ.
Now let's in green put in the other vector. So there's the I part, there's the j part. So, and this side is root 2. How big would this side be? Who can tell me the answer directly? It'd be root 2.
It's 1.
Yeah, no, I know that, but give me the with the cos and the sine. Which do I have here, cos or sine?
Cos.
Cos
Yeah.
45. And then how big is this one?
Sine.
Root 2 sine 45. What's root 2 sine 45? 1. And root 2 cos 45? 1. So what's this factor going to be?
I plus j.
1 I.
Y plus 1 3. 1
Oh,
I.
1 I.
Minus 1.
Minus I, it's going to the left.
Yes, plus 1.
Plus minus 1i plus 1j.
Yeah.
So, let me go back up here. When I add them together, what happens to the i's? They cancel. So I'm just left with root 3 plus 1
J.
j. So this factor, when you add them together, goes just like this. It's just straight up. And how big is it? What's it going to be? Something like 2.6 or something? Can you type this in, please? Root 3 plus 1?
2.7.
2.7, is it? 2.7 is the length. Okay? So again, this is a typical type of problem you would get in the physics course and in the exam, where you have to take a vector, write it in terms of I and j, and then maybe you have to add them together or something like this, or subtract them maybe.
Did you write the J together?
I did, yeah. What happened here was, the step before it, so to speak, was root 3j plus 1j. I added these two together here. Now these, if you look here,
Yes.
they cancel.
And the next one.
And then these add together to give me this. But look, there's a j in both, so I can just take it out. You see here, there's a j here,
Yeah.
and a j here. I can add them together. Oh, sorry, I can take them out, just like j on the outside. What's the verb for when you take something out that's in common to both? Factorize. To factor. Okay, so if you want to improve your vocabulary, factorize is when you take a common thing outside.
This root 3 from where you get?
It's in the graph, you see, in the blue. See, it says,
Yeah, but you written this after.
this here.
Yeah.
I did this first. I put the answers here and here, and then I add them together to give me this one. And then you see there's a j here and here. I can take it out. It gives me this one.
Okay, you can.
See, look. J here, put them together.
Factorization.
This came from adding these together. This one came from here, blue, and look, the green one came from the green one here.
Okay, can you
Yes.
you
You can, after him, yeah.
if we have if we wanna get the I, the length of I, we made it the the length we give it, we have this 2, yeah?
The length of I,
No.
the green vector,
Yeah,
yeah, the length is root 2.
so we made 2 cos 60.
Are we talking about the green or the blue one?
No, the blue one.
Oh, the blue one, okay, the length is 2, yeah. So it's 2 cos 60 and 2 sin 60, yeah.
We don't need it to make it equal this over 2. Or we have,
Oh, no, I took the 2 up. You see, it was cos 60 equals x over 2. Originally,
but we got it from the...
originally there was no 2 here. It was cos 60 equals x over 2. I scratched the 2 out and brought it up here. So I get x, whoops. I get x equals 2 cos 60.
So it's, and then the answer is,
And 2 cos 60 works out as 2 cos 60 equals 1. 1 I.
1 I and...
2 sin 60 is root 3, yeah.
or 3.
Okay, yes.
The thing you did there is factorize.
I'm just saying the verb to factorize means to take something that's in common out of both and just put it on the outside. So yeah, factorize is what I did from here to here.
And the number 2.7.
Oh, I'm just saying this here is roughly 2.7. So the answer looks something like this, 2.7 J vector. Okay? Questions?
Can I have another example? If the number is next to, like, if the number is 6 or something like that. Or
Another example like this?
Yeah. Not right, no, just, if the number is 10.
Okay, I'll just,
We got this cos 6.
can I go down a little bit?
Oh, okay.
Just,
Come on.
okay.
Here, look, Mohammed, I don't really need this here, I remove this. Now what,
The vector channels.
you can do it very quickly. Look here, if you have a vector, and let's say its length is L, and let's say its angle here is alpha. Very, very quickly, this here will always be L cos alpha, and this side here will always equal L sin alpha.
This one.
Yeah, this is like quick way to do it. You can't do it any quicker than this. This is the quickest way.
Yeah, this way,
Yes.
I mean,
Yes.
we couldn't use it.
No, you can. It's fine. Yeah, use this, right here. Yeah. You can use that quick way I showed you at the end. It's just the way I've been doing it is just to explain where it comes from. But if you understand it and you just want to do it how I did at the end there, that's fine. It doesn't matter. Oops. It's okay. Thanks. Okay. So remember, if I say something like it has no I component, what does that mean?
0 I.
The 0 I, yeah. And if it says, if two things are parallel, what does that mean?
They're parallel.
No, that doesn't work. You can't say if they're parallel, it means they're parallel. If two things are parallel, what does that mean?
Two things.
There's
Yeah, go on.
same side or
What word are we looking for? Same angle or same slope? Slope. And what way can you calculate slope? Do you remember the formula for slope? So, if I give you a triangle here, and let's say this is x and this is y, what's the slope of this triangle?
Y over X.
Y over x. So if two vectors have the same, are parallel, it means that y over x is the same. So for example, I'll write two vectors down, and you tell me if they're parallel. So if I was to say 5i plus 10j and I plus 3j, are these parallel? No, what's the slope of this vector? 2, because it's 10 over 5. If you draw it, you got 5 and 10, and the slope is 2. If I draw this one, here is 1, 3, and the slope?
3.
3. They're different slopes, so they're not parallel. Now, if I was just to change this here to 2, what would this be? 2, and the slope? 2. So they would be parallel then. So this is how you can check if factors are parallel or not. Again, in the exam, they could easily say, is your answer parallel to this answer? Something like that. So you need to know parallel. How do you remember the difference between parallel and perpendicular? No. How do you spell parallel?
P-A-R-A-L-L.
Double L. Double L. Parallel has double L in it. So even the word looks like it's parallel. Okay? Think about it, you know? Yeah, I'm telling you. And perpendicular. Does perpendicular have 2 L's?
No.
So now you will never confuse them again, right? Yeah. Oh, man, I'm telling you. Okay. So I have questions here for you to practice on these.